All of you copy the numerical. We'll start solving the questions. So did we solve any question on electric flux? Did we solve any questions on electric flux? I think last class we have not.
Sir, we did one regarding the cylinder. Sir.
Finding the net flux through the cylinder is zero.
Yes.
Mark this question as important. So we have a cube. So one cube is given. This is x-axis. This line is passing through this side of the cube is x-axis. This is y-axis and this is z-axis. So we have a cube which is present in XYZ plane. Okay, this is a cube. The side of the cube is given as A. The side of the cube is A. And this distance from here to this side of the cube is A. So you can say that the cube is present at a distance of A from the y-axis. And this distance is also A. So A plus A, 2A. So the next side of the cube is present at how much distance from the y-axis? 2A. So this much is given in the question itself, dimensions. Now, the electric field is E of x equal to alpha into x to the power 1 by 2. E of y and E of z is 0. What is the meaning of this? The electric field in this whole region is present only in x direction. There is no electric field present in y and z. Okay, you can see the value. Electric field is equal to alpha into x to the power 1 by 2. So if you notice carefully, the electric field is depending on the x coordinate. But in y and z, it is 0, no value. What is alpha? Alpha is a constant which is 800. We need to find out, first part, the flux through the cube. Second part, the charge within the cube. This is the question. So all of you copied the problem. Should we discuss? I want you guys to write a bit fast, copy with me only. So I will explain the question. We have a cube whose side is A, which is present at a distance of A from the y-axis. Electric field is present only in x direction. There is no electric field in y and z. So find what is the total flux through this cube. Total flux means what is the number of field line? What is the strength of the number of field line which is passing through the cube in which direction? Perpendicular to the cube. Okay. Now, and in the last part, what are they asking? What is the charge which is present inside the cube? See, if flux is there, who creates the flux? Charge, right? Charge is responsible for field lines. If flux is there, obviously there should be charge within the cube also. So let's start solving the first part. So before we start solving, let's draw the direction of electric field. Electric field is only in x direction. There is no electric field in y and z. So what is the flux through the cube? So we will focus on this cube by every face. If you see the top face, where will be the area vector? Upward. I'm recalling what is the direction of area vector? Perpendicular to the surface. Okay. If this is area, where is area vector? Perpendicular and outward. If you see this top part of the cube, where will be the area vector? Perpendicular and outward, not inward. Perpendicular and outward. Area vector will be in the upward direction. And where is the electric field? Forward direction. So area vector up, electric field here. What is the angle? 90. What is cos 90? 0.
Zero.
Okay. Cos 90 is 0. So what is the formula for electric flux? We just now saw. Electric flux is E dot S, which means how much? ES cos theta. So for this particular surface, angle between the area, this is area vector, and this is electric field. What is the angle? 90 degree. So cos 90 is 0. So electric flux 0. Any problem? No rocket science? Sorry, what happened? Any doubt?
No, sir, I just joined late. What have we done till now?
This is the first question we are doing.
Okay, okay, thank you.
So for the top surface, this is the area vector. Angle is 90 degree. So for the top, it will be 0. Will the same thing happen for bottom? Yes. For the bottom surface, what will happen? Area vector will be down and electric field is in the forward direction. So what is the angle? 90 degree again. So what will be the flux for the bottom surface? 0. Anyone having problem? Why 0? Any doubt? Anyone? Clear? Whatever questions you guys have, ask. This chapter is connected to the next chapter. Don't carry any doubts. Ask at that time itself. So for bottom also 0. Now for the front, where will be the area vector? Towards you. Correct? This is the front surface. Okay. Electric field is in which direction? Like this. Here. X direction. Electric field is in the positive X direction. This is the front surface of the cube. Where is the area vector? Perpendicular and outward. Electric field X, area vector like this. What is the angle? 90. Is it clear? Angle is 90. If angle is 90, cos 90 is 0. So what will be the flux due to the front surface? 0. Since theta is 90. Now for the bottom surface is towards me, right? This surface, this is the, not bottom, sorry, back. This is the back surface, it is towards me. So for the back surface, where will be the field lines? Field line is same. Field line is going in the x direction. Area vector will be towards me, outward. Area vector is coming towards me. Electric field is going in the x direction. What is the angle again? 90.
90.
So for the back surface, again, flux will be how much? 0. Why? Because theta is 90. Any problem? Top, bottom, front, back. Clear? So which two surfaces are remaining? Sideways. Sideways. You can imagine this room only. We discussed ceiling, floor, front, back. Which walls are remaining? Sideways. These two. So sideways walls are remaining. For this side, area vector is outward and perpendicular. So where is the area vector? Like this. So if you see electric field and area vector are parallel to each other. Parallel means what is the angle?
0
0
degree.
degree. And cos 0 is how much? Not 0? 1? You guys are telling 1, so it should be correct one. So for this, For the right surface, I will write Es cos theta. So theta is 0, cos 0 is 1. So what is the electric field? Alpha into x to the power 1 by 2. So for this surface, right, what is x coordinate? A plus A, 2A. The x coordinate of the right surface is A plus A, 2A. So what will I write? Alpha into 2A to the power 1 by 2. Electric field alpha x to the power 1 by 2. Alpha into 2A to the power 1 by 2. In cube, what is each surface? Square. What is the area of square? Side square. So area will be how much? A square. Any problem in this? So what will I write? Alpha into root 2. A to the power 1 by 2 plus A to the power 2. How much? A to the power 5 by 2 or 3 by 2. Correct? 1 by 2 plus 2. So this is for right. Now which one is left? This one. Where will be the area vector? Right side or left side? Left side.
Left.
Why left side? Because area vector is always perpendicular to the surface and outward, not inward. Perpendicular and outward. So which one will be outward? Left. Area vector will be this side. So what is the angle between the area vector and electric field? 180 degree. They are anti-parallel. Okay. So for the left surface, it will be E S cos 180. If you see for the left surface, what is the x coordinate? A. You will put x as A here. So it will be alpha into A to the power 1 by 2. What is the area? Side square. And cos 180 minus 1. So this becomes minus alpha A to the power 5 by. This question you should be able to solve within 1 minute. Now you will say, sir, you are only taking more than 2-3 minutes. I was explaining for each phase. You should be into that situation that you can analyze that for which surface it should be 0 within 10-15 seconds. You should be that much fast. After that, if you see, it is two-step, two-step. That's it. You have to just add them. That is the answer. Because for all the four surface, it is 0. Only for left and right, it exists. Add them, done. Within 1 minute, we have to solve one part for this. Copy it? Anyone with any doubts? So what will be the total flux? For four surface, it is 0, 0, 0. For left and right, it is how much? For right, it is alpha root 2 a to the power 5 by 2. And this one minus alpha a to the power 5 by 2. What can we take common? Alpha into a to the power 5 by 2 root 2 minus 1. This is the answer. Okay. You can simplify it. Calculation I'm leaving for you. I'm not doing the calculation. You just have to substitute the value of alpha as 800. What is the approximate value of root 2?
1.41.
We are supposed to remember the values. I see a lot of blank faces. You are supposed to remember this. What is the approximate value of root 5? It should be on your fingertips. Root 2, root 3, root 5. Now you will say that, sir, in board exam, if they have not given, should I substitute or not? In board exam, it's up to you. If a root ka value is not given, you can leave the answer in root 2, you will get full marks. But if a root ka value is mentioned, substitute it. Now what about entrance exam? In entrance exam, root ka value they don't mention. If the options are in root 2, you don't have to solve. If the options are not in the root, you are supposed to remember this and substitute and simplify. Okay, so it will help you in your entrance exam. So remember that. For root 5, you can just remember 2.2. It is enough. These things should be on your fingertips. I'm not doing the calculation after that. You just have to substitute alpha as 800. Root 2 minus will be how much? 0.4. 800 into 0.4 will be how much? 320. You can solve. Any doubt? Anyone? I'll solve it only. This is 0.4 a to the power 5 by 2. 8 fours are 32, 3200. So 320 into a to the power 5 by 2. What is the unit of electric flux? Newton meter square per coulomb. It is electric field into area. Electric field is Newton per coulomb multiplied by area meter square. Anyways, try the second part. Hint is use Gauss law. For the second part, use Gauss law. What is Gauss law? Net flux equal to charge enclosed by epsilon naught. And what are they asking? Charge enclosed. So net flux is charge by epsilon naught. Net flux you already calculated. Epsilon naught is a constant which will be given in the exam. So what is the only unknown left? Charge. Solved. According to Gauss law, net flux is equal to charge enclosed, means charge present inside the surface divided by epsilon naught. This you already know. This is the value. Cross multiply. So charge is epsilon naught into electric flux. What is electric flux? 320 into a to the power 5 by 2 into epsilon naught. This is the value. Coulombs. Epsilon naught value will be given in your exam. You are not supposed to remember it. Okay. This is called, what is it called? Epsilon naught.
Permittivity.
Permittivity. Permittivity of which medium?
Vacuum.
Free space. Free space or vacuum. Okay. This is called permittivity. The value will be given in the exam. You can substitute it. That will be the final answer. But in the concept, any doubt, any student? How did we find the flux due to each surface? See that because the next question is going to be similar to this. And I will call you guys on board. If any doubt is there, let me know. You can see the solution quickly. No doubts? All clear? Surya? Already ready for coming on board? Chalo. Let's solve the next question. The next question is similar to this one. All of you try to solve it. And I think most of you can solve it also if you have understood the previous one. The second one is easier version of the previous. So we have a cylinder now. In the previous figure, what was the shape? Cube. So we have a cylinder. The cylinder is horizontal. Okay, the cylinder is horizontally kept. So this is the x-axis, this is y-axis. This point is the origin. This is origin. This distance is given, total distance. So basically you can see this total distance is the length of the cylinder. So length of cylinder is given as 20 centimeter. This is the figure. Now we have two electric fields here. The first electric field is minus 200 I cap. This is for x less than 0. Means on the negative side of x-axis, electric field will be this much. Then we have electric field equal to 200 I cap, which is for positive values of x. This point is clear. For x greater than 0 means on the right side, the electric field will be this much. On the left side, electric field will be minus 200 I cap. You can see also magnitude is not changing, only the direction is opposite. If it is I cap means positive x axis, this is minus I cap means negative x-axis. Radius is 5 centimeter. So you need to find the first one. What is the net outward flux through the flat face? Through the flat face. Second part, flux through the side of the cylinder. Last part, total charge in the cylinder. I'll explain. Yeah. See, if you guys are getting confused, what is flat and side? Just understand that if this bottle is there, this bottle is what cylinder? Okay. If you see that this circular surface is flat or not? Flat. So this circular part is basically called the flat part of the cylinder. In this, the flat face means the circular part or the cross section of the cylinder. Side means the curved surface. This thing. This curved surface is basically called the side of the cylinder. So sometimes they write the curved surface of the cylinder, sometimes they write side. Side means the curved surface area. Flat face means this flat. This is completely flat, circular. Is the meaning clear? You can make a note of that. These words are a bit confusing. I totally agree with you. They should have written cross section, but they have written flat. Flat means this circular. Side means curved surface. What will be the answer for the second part? What will be the
It
answer
is
for
a
the second
zero.
part? Zero. Zero. Angle will be 90. Just now we discussed. Still not clear. See here. This is curved surface. So where will be the area vector? Perpendicular to the surface. Area vector will be where? Up. See the direction of electric field. Electric field in which direction? Positive x or negative x. Electric field will be either towards right or left. But area for this, area vector means perpendicular and outward. What is the angle? 90. Cos 90 is how much? 0. So what is the answer? 0. So for the second part, we've already discussed these things in the previous question. That is the reason I told it is similar to the previous question. So for the second part, you guys write the answer directly. For the second part, you will write since the curved surface, the area vector is upward. If you take a particular area vector will be upward, and the electric field is in this direction. So angle is 90. Cos 90 is 0. So therefore, flux due to this will be 0. Okay, in the exam, don't directly write 0. They will give you 0 marks also there. Write down the explanation. Since angle is 90, cos 90 is 0, so flux will be 0. Okay. Now, what is the answer for the first part? Anyone solved? First part? No? Then Shubham, now you tell the value. What you got? 10,000 pi. Substitute the value of pi, na? 3.13140. Okay. Substitute the value of pi and check. How much? For the first part. For the first part, do not read the question properly. For the left surface, electric field is already negative. So negative negative positive हो जाएगा. Because angle will be cos 180. The net, so you're telling net will be zero. हाँ, ठीक. Any other answer for the first part? All of you are getting net zero.
Yes, sir.
Anyone who is not getting the answer as not getting the answer as zero. Anyone in the class? You're not getting zero. What is the value you're getting? Total. Tell me the answer for the total. 62800. You have done a mistake. Answer will not be zero. The net flux will not be zero. 3140. You have not converted the units. Who will convert centimeter into meter? Okay, your answer is correct. The only mistake you have done is that you have not converted. Convert and tell the final answer. Students who are stuck, no need to worry. I will discuss. I will solve till the last step. But it is similar to the previous question. That's why I want you to do. Use the formula. E dot S means electric field into area into cos theta. You guys know the area for circle, pi r square. Try it. Any other answer from here? Anishka, Ananya, Shreya, Tanvi, Pranav, Advait, Dia, Arnav, everyone, Tanuj.
Sir, I'm confused as to how to take the direction of the
How to
area
take the
vector, sir,
direction
for the first subdivision, sir.
for the first part. Area, what is the doubt in the area thing? Area is always outward and perpendicular. Statement is very simple, outward and perpendicular. Aditya, what happened? Still you're getting the same answer, zero? First of all, your numerical value is also wrong. You are getting 5,000, no? Now, what is the numerical value? 5,000 into pi ka value. Put the value. I'm telling, put the value of pi. 3.14. Any other answer? No one. Surprise! I thought that I'll get a lot of answers. What is the final answer you got, Surya? I will tell the final answer. Final answer should be 3.14. 1.57 plus 1.57. So all the students who are getting zero, answer is not zero. For the left side, it will come 1.57. For the right side also, it will come 1.57. I will tell you one thing. Use common sense. Don't do the calculation two times. See here. All of you see here. Electric field ka magnitude is changing? No. So whatever answer you will get for the right side, the magnitude will be same for left side also. So don't waste your time in the calculation two times. Use common sense. If the electric field ka value is different, then you will do the calculation two times because area is same, circle, electric field ka magnitude is same. So magnitude of flux will be also same. Okay, sign may be ulta, plus minus, but magnitude will be same. So when you are solving MCQ, save your time. Don't do the calculation again and again, same calculation. So let's do the calculation. Anyone with 3.14 as the answer? First time I'm asking. Anyone? No? You got it? 3.14. I hope that you didn't do any jugad. You didn't cancel any zeros and all. Huh? Okay. Because once we know the answer, we start removing zeros if we get extra zero also. Okay. I will check in the end. So let's solve. Take care of the unit also, centimeter, not meter. So area vector will be outward and perpendicular. Area vector, perfectly fine. This is positive side or negative side? Positive. Which electric field will you pick? Second one because it is defined for positive. Electric field is also in the same direction because electric field is in I cap. What is the angle? Zero. Cos zero is zero. One. Don't write zero. Cos zero is one. Okay. Grade 12 student also do these mistakes. You may feel now that I cannot do this, but still happens. Okay. Sometimes in overconfidence, sometimes you don't know. There should not be any reason. These mistakes should never happen. Okay, I remember, you guys remember in the previous class we saw the cylinder wala question. Okay, so one student wrote the answer 0 by telling that sir cos 0 is 0. For the answer it is 0. So cos 0 is not 0, cos 0 is 1, cos 90 is 0. So don't do this mistake in the exam. So for the right surface, flux due to right surface, electric field is 200. Area vector, what is area of circle? Pi r square. And what is the angle? 0. Cos 0 is 1. I'm directly writing. Okay, cos 0 is 1. So let's solve it. 200 into 3.14 into r square. Radius is 5 centimeter. So 5 into 10 to the power minus 2. So that becomes 25 into 10 to the power minus 4. Any problem? See. So calculation with you guys are champion. Do the calculation. So 25 into 2 will be what? 50. So 50 and then two zeros into 3.14 into 10 to the power minus 4. All clear? Multiply. 5 fours are 20. 5 ones are 5. 7. 5 threes are 15. 15.70 into 10 to the power minus 1. So what is the answer? 1.57 Newton meter square per coulomb. Clear? Now I will tell that why few of you are getting zeros. Suspense. You have to reveal that why the answer was coming 0. All of you copy this quickly. Check if any doubt is there. I think calculation was also simple, right? Nothing complicated. Why none of you got? I'm seeing different answers. That will be twice, but few of us are getting 0. That's what we need to discuss. Stop it. Anyone writing? Anyone? Now for the left one. For the left one. Just observe this thing here. This minus 200 I cap. This minus is magnitude or direction? Direction. The mistake what we are doing here is that we are taking that as magnitude. Yes, Aditya, you have taken minus 200. That's why you're getting 0. Do you understand your mistake? So students who are getting 0, the mistake what you have done, that you consider this minus 200 as a magnitude. But remember that electric field is a vector quantity. Whenever there is a minus before a vector quantity, that doesn't define magnitude. That defines direction. Okay. Flux is a scalar quantity. If I write flux is minus 200, so magnitude is minus 200. But when there is a minus sign before a vector quantity, then it represents direction. So this minus tells that direction is what? Minus I cap. Minus I cap means what? Negative x direction. Clear? Things are very small, but we end up doing mistakes. So we have to take care of these things. Make a note of these things in your notes. I'm again telling mistake will be very silly. You will feel after seeing the solution that I cannot do this, but you have already done that. In future, it should not happen. So take care of that. Write a note in your notes that what mistake is possible here. It should not happen in the exam. So electric field for this will be in this direction because electric field is minus I cap. And where will be the area vector? Outward. So what is the angle? Do I need to do the calculation again? No, because electric field ka magnitude is same, area is same. So again the answer will be 1.57. What will be the total value? 3.14. For the right, we did. I'm not doing the calculation for left. Now the thing is, in the school exam, what should I do? Ask your teacher. Okay? Whoever is teaching you in school that if I write the statement that case is symmetrical, magnitude is same, so answer should be exactly same as 1.57. If teacher agrees, do that. Otherwise, do the same calculation. What you have to do, just copy paste. Okay? Copy paste everything. Ask your teacher. Don't blame me in the end, sir. You told that it's symmetrical, so my teacher cut 1 marks. Ask your teacher. Okay, but according to me, there is no point of doing the calculation again. If you write the statement, case is symmetrical, value should be same, add both, final answer is doubled. So check with your teacher once. In board exam, they don't cut marks for these things because already the calculation is very lengthy. Okay, they don't want you to write so much for a 3 marker. So what is the total flux? Left plus right. So left plus right, 2 into 1.57. What is the answer? 3114. If you solve a MCQ, in the option there may be option pi. Answer is pi, 3.14. It's a good problem. You can see the level of questions in your NCRT. The last two questions what I've done are from NCRT. They are good problems. They clear your basics. They clear your concept. They make your fundamentals strong. Practice these kind of questions. All your doubts of direction and all everything will get cleared. Now, still some students get confused, sir. 1.57 on left side, 1.57 on right side. Net should be 0, right? So why answer is not 0? Because flux is not a vector quantity. Flux is a scalar quantity. There is no point of discussing about direction. But the same thing if I tell with respect to a force, one force of 10 Newton on left, 10 Newton on right. What is the net force? 0, because force is a vector quantity. Same thing is applicable for electric field also. Electric field is also vector. Electric field of 10 on left, 10 on right. Net electric field is 0. But flux is a scalar quantity. So both will get added. Okay? Both will get added. Don't say answer is 0. There is no concept of direction in this. Done? Write down the. I think we have one more question. You guys can write down the heading application of Gauss law. We'll discuss the numerical after that. Application of Gauss law. Now, see, you have studied the formula, the law, the numericals, but what is the main application of Gauss law? The main application of Gauss law is to find the electric field due to any charged body in a simple manner. That is the main purpose of Gauss law. You take any charged body, you want to find the electric field due to that. Gauss law will help you in that. Okay. So we can solve the same thing without using Gauss law also, but the methods are very complicated. A lot of integration is there. Lot. So I will take few questions on that in this Saturday's class. I will show you that if I give you an irregular shape object and they ask you calculate the electric field due to that, you will not be able to use Gauss law. There we use proper core integration. But most of us have not seen that much integration. So I will take only one question. The moment we finish integration in maths, then I will give you some difficult questions on that, where Gauss law you can't use directly. But in your school exam, the board syllabus, only Gauss law ka thing is there, not that integration. That thing is removed from your CBSE syllabus or your PU syllabus. At our time, we had that also. They removed because many students are there who don't have maths. So for them, it was very difficult to do those complicated integration. That is removed. But for your entrance exams, those things are there that we will discuss on the weekend class. So the heading is application of Gauss law. Like I told you, what is the application? You can write down to find the electric field due to a charged body in a simple way or simple method. That is basically the application of Gauss law. Now, in our syllabus, we have three charged bodies. The first charged body is infinitely long straight current carrying conductor. First body is infinitely long straight current carrying conductor, not current carrying, sorry, charged conductor. There is no current carrying now. Infinitely long charged conductor. Second, a infinitely big charged plane sheet, and third, a shell. What is the meaning of shell? Petrol pump. What is the meaning of shell? Hollow sphere. Shell means a sphere which is hollow from inside. You can take the example of basketball, volleyball. Is it hollow from inside? Yes. Okay. So there are two things. One is hollow shell. Hollow shell in the sense there is nothing inside. Hollow sphere. Then second is solid sphere. Solid sphere is again removed. Okay. So in your school exam syllabus, we have infinitely long charged straight conductor, infinitely big charged plane sheet, and third, a hollow sphere or shell. These three things. Let's start with the first one. So the first one is electric field due to infinitely long straight charged conductor. Electric field due to a infinitely long straight charged conductor. The heading is electric field due to a infinitely long charged conductor. Straight. Infinitely long straight charged conductor. So you can see that we have a infinitely long straight charged conductor. If I have to apply Gauss law, what should I do first? Because Gauss law is applicable for which type of bodies? Closed one. Very good. Closed one. Is it closed or open? Open. Like open. Where is it? I know charge is inside, means the body. I can touch it right from both the sides. Is it enclosed inside something? No, it is open. First thing what I have to do that I have to enclose it inside a surface. And that imaginary surface, that is not something which exists in reality. It is an imaginary surface which we draw or which we assume. And that imaginary surface is called Gaussian surface. Okay. I will enclose it. What is the reason? So that I can apply Gauss law. Otherwise, I can. So I will enclose it. So what type of Gaussian surface I am drawing? A cylinder. A Gaussian surface is always drawn with dotted lines. You can't draw it under a solid curve. So Gaussian surface should be always drawn with dotted lines. So this is basically a Gaussian surface. So the Gaussian surface which we have drawn here is cylindrical. A cylindrical Gaussian surface. I'm repeating again, students. This Gaussian surface is not something which is present physically there. It is imaginary. Don't think that it is a cylinder because the moment we see the figure, we think it is a cylinder. Inside cylinder, it is there. It is an imaginary surface which we have assumed. So Gaussian surface is something which is imaginary. It is not present physically there. Then there should be some part of the conductor outside the Gaussian surface. Okay, when you draw, make sure that there is some part outside because this Gaussian surface is not infinitely big. Conductor is infinitely big. So there will be only a particular portion of the conductor which will be inside. So don't draw in such a way that it should look like that everything is inside. There should be some portion outside. All of you are drawn? Is the meaning of Gaussian surface clear? Is it present physically there? No. It is an imaginary surface drawn to apply Gauss law. Let's take the length as L, radius as R. R is the radius of the Gaussian cylinder. Okay. Now let's derive it. All of you see on the board, no need to copy. Give me 2 minutes. I will explain everything. After that, you aram se copy. I'll give you time. Understand this thing. Positive surface. Suppose this is positive. Positive charge है यहाँ पे, ठीक है? Electric field moves away from positive charge and come towards negative. For negative, it will come towards. For positive, it will move away. So this is positive. So electric field lines will move away or towards? Away. Electric field lines will move away. Now, if you see the part of the cylinder, this is which part of the cylinder? Curved. Side is basically what? Curved. If I take particular portion of the cylinder, suppose this much, where will be the area vector? Outward. Outward and normal. Area vector will be outward and normal. Any problem in the directions? So what is the angle? 0. Clear? Now if you see for this one, electric field is where? Outward only. For the circle, where will be the area vector? Outward. Outward, but for this circle, if this is circle, where will be the area vector going? Outward, means up. So area vector will be up. What is the angle? 90. Cos 90 is 0. So flux will be 0. Same thing will happen here also. Electric field is outward. So this time circle is in the down. Area vector will be going out. So area vector is this. What is the angle? 90. So flux again 0. So in this cylinder, which surface is participating in electric flux? Curved or circular?
Curved surface.
Curved surface. Curved surface. Due to the cross section or flat, it is 0. Any doubt? Anyone in the class? See the direction properly, let me know. Because this is a derivation which directly comes in your exam and we mug up the derivation. There is not a single point which you have to mug up. If you know it, you can aram se derive. So electric flux is equal to what? If I'm not using Gauss law, basic formula. Integration of E dot ds or E dot s. Correct? So flux will be equal to, what is the angle between both of them? 0. So ES, what is the curved surface area of a cylinder? 2 pi r 2 pi RH. So curved surface area is 2 pi RH. What is H I have taken? Clear? Cos 0 is 1. I didn't write. Cos 0 is 1. Any other formula for electric flux? Yes. What is the other formula for electric flux? By Gauss law. Charge enclosed by epsilon naught. Okay? This is one formula. There is one more formula by Gauss law. So by Gauss law, we say, by Gauss law, electric flux is charge enclosed by epsilon naught, and which is E into 2 pi RL. Now all of you see on the board, lambda. I have not explained these things till now. Lambda. Lambda is called wavelength. Okay? But in this context, there is no meaning of wavelength. So lambda is called, anyone knows the name? Anyone? Linear charge density. Lambda is called linear charge density. So lambda will be what? Charge per unit length. Because remember, in moment of inertia, mass per unit length, mass per unit area, mass per unit volume. Here, instead of mass, it will be charge. So lambda is the linear charge density. So lambda will be charge per unit length. So what will be charge equal to? Lambda into length. All clear? Any doubt in this? So what will be charge equal to? Lambda into length. So E into 2 pi RL. What can we cancel? LL. So what will be your electric field? Move everything here. Electric field will be lambda by 2 pi epsilon naught R. This is the electric field. This is the electric field due to an infinitely long charged straight conductor whose linear charge density is lambda. Okay. And what is R? What is R here? R is the radius of Gaussian surface or R is the distance from the conductor. Suppose this is the conductor. You want to find the electric field at this point. So the distance between the conductor and the point where you need to find electric field, that is R. So when you will draw the Gaussian surface, you will draw the Gaussian surface with the radius of this distance. Okay? R is the distance where don't miss the weekend classes. I see that some of you don't come on the weekend classes regularly. I've already told if I'm doing something difficult or out of syllabus, I will tell that. Students who are not preparing for an entrance exam, you can skip it. But by default, all of you have to attend weekend classes. It will help you. Do not skip. Students who have skipped this weekend classes, recording is in the group. See it, complete your notes, but do not miss the classes. So why I'm stressing? Because on this point, because after seeing the board exam paper of this year, as a teacher, I am only scared. Okay, let the result come. You will see how many people will pass or fail. Physics paper was tougher than JEE mains paper, the board paper this year. Yes, it was way tougher. One of our student got 99.8 percentile. That student wrote the physics paper, was telling that I felt that it was tougher than the JEE paper what I wrote last month. And I've also seen the paper. As a student, you will find the paper difficult, but as a teacher for us, it was easy only. Okay, so I don't want any one of you to miss the weekend classes. We do some tricky questions, difficult questions, so attend it. Okay? Right? Everyone, anyone copying? Now, let's discuss a graph. If they ask you that draw the graph between electric field and the distance. What is our distance from the charge conductor? Where you want to find the electric field. Okay? Or you can say radius of the Gaussian surface. So if you see the relation, electric field
You're
is what?
muted.
Inversely proportional to R. Okay? We have to draw the graph between electric field and distance. If you see the relation, electric field is inversely proportional to distance. What is the graph of inversely proportional? Decreasing, decreasing. It will not touch the x-axis, it will be something else. It will be a decreasing graph. Why? Because it is inversely proportional. Okay, write down the heading. Next, second part. All of you drawn, right? Second heading. Electric field due to a infinitely large charged plane sheet. Electric field due to infinitely large charged plane sheet. So what is the meaning of plane sheet? The page, the notebook in which you are writing. It's basically a what? Plain sheet. Okay. Suppose if you see this textbook, if I open one page, so this is basically what? A plain sheet. If you extend it from all the ends, from the top, bottom, left, right, it will be what? An infinitely large plain sheet. So we need to find what is the electric field due to a infinitely large plane sheet. So let's obviously we can't draw infinitely large plane sheet here. So we'll assume it to be infinitely large. Let's draw a sheet here. So this is basically a plane sheet. We can put any charge on this, either positive or negative. We'll consider positive. Now, we'll put positive charge on this. I will tell you why I made this circular cross section here. So we have an infinitely large charged plane sheet. And through the plane sheet, if you see this figure, what do you think? Through this plane sheet, a cylinder is passing. Right? Is it looking like that? I think I have drawn, first time I have drawn this much better. Okay. Otherwise, it used to look something else. So if you see this, there is a cylinder which is passing through this sheet. And what is the reason for that? What is the reason for this? Because again, we have to think of a Gaussian surface. We have to think of a Gaussian surface. So assuming a cylindrical Gaussian surface or drawing a cylindrical Gaussian surface is simple. If you check your NCRT, the Gaussian surface, what they have taken is called parallelopipe, so which is a complicated figure. So I have skipped that. You can take this also. This is also perfectly correct. There's nothing wrong in this. So this is basically Gaussian surface. I should have drawn with dotted lines. You guys have drawn this or about to draw? So draw with dotted line. Take it. If you have drawn, no problem. Just add a note that cylinder should be drawn with dotted lines. That is Gaussian surface. I will erase and draw it again. Okay. And start the working. So first thing we will discuss sigma. Okay. Sigma. So what is this sigma called? Sigma is the surface charge density. Lambda was what there? Linear charge density. This is called surface charge density. This is your surface charge density. So you will write this as what? Charge per unit area. That was charge per unit length. This will be charge per unit area. Now, it's an infinitely big plane sheet. So electric field will go in both the direction, only one direction. Sheet has how many sides? Two.
Two.
One sheet has two sides. Okay, two. Front and back. If you see my palm only, if this is a sheet, if this is a paper in which you are writing, front and back. Okay. So when I talk about plane sheet, when you charge the plane sheet, you will charge both the sides. It's not that you will say, sir, I'm charging only the front side. When I'm talking about a plane sheet, I'm reminding you again, you will charge the whole sheet, both the sides. So if this is the front face, if this is the front face, electric field will go outward. And what about back face? The electric field will go outward again. Okay? Is it clear? So don't think that electric field will be only on this side. It will be on the both sides. So electric field due to this front face will be in which side? This side. And due to the back, it will be on backwards. Because electric field lines due to positive charge always moves away. Any problem? Now, if you see this Gaussian surface, I'm not talking about curved surface here because in the previous also I explained. For the curved surface, what will be the angle in this case? This is curved surface. What will be the angle? 90. Curved surface, area vector will go up, angle will be 90. So I'm not discussing for that case. You can add to your notes. I'm discussing only for cross section. For cross section, area vector will be outward, right? And normal, outward and perpendicular. What is the angle in this case? 0. What is the angle in this case also? 0. So what is the flux because of the left surface? E dot S, which is Es cos theta. So what is the area? Is the area given? You will say, sir, circle. Radius is not given. So I'm taking area as A. I'm taking area as A itself. So EA cos 0. Cos 0 is 1. Do not get confused that why you are not writing pi r square. Because the radius is not given to me. So I am taking the area as A. So I directly wrote A. If you are thinking that here you are writing S, if you want to write, you can write ES also. That is also correct. You can write S also here. It is perfectly correct. No one will cut your marks. Okay. Same thing. What will be the flux here? Angle is 0. So it will be E A. A is what? Area of cross section. A is not the area of sheet or cylinder. A is the area of cross section. All clear? Any doubt? So what is the total flux? 0. EA on left side, EA on right side. What is the total flux? Not 0. Because it is scalar quantity. Okay, so we don't see the direction. Whatever is the magnitude, we directly add. So it will be EA plus EA. What will be the total flux? 2EA. Don't write 0. Huh? And you can take negative also. Take negative also. In negative, what will happen? It will be what? Both of them will be coming towards. Okay? In a negative charge, electric field comes towards the negative charge. So now EA coming from here, EA coming from here. Answer will be how much? Again 0? Okay? 2EA. 2EA. Or you can say minus 2EA. But the magnitude will be what? 2EA. Remember that flux is a scalar quantity. You will always add them. You will always add them. Okay. So this is the thing we did. Now, what is Gauss law? Gauss law says that flux is what? Charge enclosed by epsilon naught. Correct? Now, charge enclosed by what? The whole body or Gaussian surface? Gaussian surface. Okay. Focus on small things. You will not feel that it is important. From there only they create one assertion reason and you get confused in the exam. From small thing question comes. Whatever tricky questions will be there. So this is the charge enclosed by Gaussian surface, not the whole body. Okay. So what is surface charge density? Charge by area. So what will be charge enclosed? Surface charge density into area. Correct? Substitute sigma A by epsilon naught. And what is flux? We already calculated 2EA. Put 2EA equal to sigma A by epsilon naught. A gets cancelled. E equal to what? Sigma by 2 epsilon. This is the final answer. So this is the electric field due to an infinitely large plane sheet. Sigma by 2 epsilon naught. Done? All clear? Do practice these derivations after the class. If you practice this 2, 3 times and if you observe the steps, you don't have to remember, you have to observe the step, what we are doing. First, we are finding the flux by using basic formula E dot S. After that, we are equating that flux to a flux which is found by which formula? Gauss law. These are the two important things. Okay. Nothing difficult. There is nothing to remember in this. But what happens sometimes they directly ask the numerical. So if you remember the final expression, not ask me to remember within 1 day or 2 day, but take your time. You have to remember the final expression also because some numericals come. Now, for solving a numerical, you will not derive the whole expression, right? You need to know the expression. Fine. Derivation as well as final expression both are important. Now, if you observe one thing, the electric field due to a infinitely large plane sheet, does it depend on the distance? Any arc term is there? No. It means it is independent of the distance. Because the plane sheet is huge that if you move at a particular distance, suppose you are at a distance of 1 centimeter, 2 centimeter, 3, 5, 6, 10, 15, 20, 100. Now don't say that, sir, I will go 1 kilometer away. Okay, if you go that much, so obviously there will be no effect, right? But within the range, if someone is at 1 centimeter or 10 centimeter, the electric field ka value will be same. Okay, but if you go very far, obviously there will be no effect. Everything has a capacity. But in general, it is independent of the distance. So if they ask us, draw the graph between electric field and distance, so graph will be what? Constant. Because this value is fixed. The graph will be a constant graph. And what will be this value? Sigma by epsilon. It is independent of the distance. This equation is self-explanatory. There is nothing to remember in this. This graph is basically common sense. Nothing to remember in this point. Done? Any doubt? Last one is left. Let's discuss it and close this chapter. Okay. So concept wise, we'll finish everything today. In the next class or on Saturday, we'll do numericals. I want you guys to also finish this. If we finish it, you also finish. Sit today for 2, 3 hours, revise everything. Or by tomorrow, try to finish it. See, always give yourself some task. If you just think it will happen on weekend, so nothing will happen. At least this year, so give full effort. 1 year is also enough to change the picture completely. 1 year is a big time, but if you utilize it properly, forget 1 year, 3 months are enough. I've seen students, a few students I remember last to last year, they joined in December. They scored more than 95%. Only in 3 months. But that much effort is not possible for everyone to put. It becomes very stressful. It affects your mental health. So the right thing is that you start putting effort from now so that everything is balanced. So don't wait for the last moment. If you are studying properly from the starting, you'll feel that you'll not feel a burden. Never. You'll feel never a burden. You'll feel that everything is going smoothly I'm just giving 30 minutes, 45 minutes for each subject every day. That is enough. 45 minutes also if you give for each subject every day or 1 hour alternately after the class, it is more than enough. If you're focusing in the class, if you're listening everything in the class, that is the reason I say that focus. Students just write the notes, then they go home. 1 hour ka class they revise in 3 hours. And then we complain that I don't have time. Because you're not focusing in the class, that's why you are not able to manage time. That is the right reason. We have also passed 12. I never felt the stress what I see on your face sometimes. Never, because I used to focus in the class. My teacher used to, they used to just read the books. Okay, they never explained us anything. These derivations, what I'm explaining now, I didn't even know in 12 that what is the reason why it is decreasing. That was my level. When we used to go and ask them, they used to tell that it is like this only. We never got the explanation why it is decreasing or why it is inversely, what is the meaning of directly or inverse square law, whatever it is. So make sure that whatever is happening in the class, it is on your fingertips the moment we finish the class. Last thing, electric field. What is the last object we have? Shell or hollow sphere. We'll discuss solid sphere also in the next class. It is removed from your syllabus, but still we will discuss. It will hardly take 5 minutes. So electric field due to a hollow sphere. Hollow sphere is called shell also. It is called shell also. So let's draw a shell. If it is hollow from inside, where will be the charge? If I charge it on the surface, obviously, right? Charge will not be hanging in the air, right? Obviously, it need a surface to reside. If it is hollow from inside, the total charge on this will be where? On the surface. But if I say that it is solid, solid means there is a matter inside. So where will be the charge? Inside as well as on the surface. Okay? So nothing to remember. Again, hollow, nothing is there. It means charge should be on the surface itself. If I charge this hollow sphere, the total charge will be residing only on the surface. So the charge which I am putting is Q. Okay. I'm taking plus Q, total charge on this. This is the center. The radius is capital R. So in this, how many possibilities are there? Three. One for a point outside, second for a point on the surface, third for a point inside. So we'll discuss the first case. So if I want a point outside, my Gaussian surface should be outside or inside? Outside, obviously. So suppose I want electric field at a point P, which is at a distance R. So my point is outside. So I will draw the Gaussian surface. So the Gaussian surface should pass through that point where you want the electric field. So I want the electric field at point P, which is outside. My Gaussian surface should be passing through that. Done. Now notice one thing. Capital R is the radius of the shell. Small r is the radius of shell or Gaussian surface? Gaussian surface. Okay. R, small r is the radius of the Gaussian surface. So don't mix up. You have to be careful. The first one for a point outside. So for a point outside, small r is greater than capital R. Okay. It is greater. So let's solve it. So electric flux is E dot S. What is the other formula for electric flux? Charge enclosed by epsilon naught. What is the charge enclosed inside the Gaussian surface? See, this is Gaussian surface. What is the charge inside the Gaussian surface? Q. Q. Clear? Now, electric field. What is the area? What is the area of a sphere? Surface area. Pi r square. 4 pi r square. The surface area will be 4 pi r square and the angle will be 0. So now it is solved. So what will be electric field? Q by 4 pi epsilon naught r square. This is the electric field. I think this one is the simplest, right? Have you seen this formula before? KQ by r square. Perfect. It is same as KQ by r square. So if you see that this electric field due to a hollow sphere at a point outside is same as the electric field due to a charge. What was the electric field due to a charge Q? KQ by r square. So this electric field due to a hollow sphere at a point outside is same as the electric field due to a point charge at a distance of r. Okay? So you can write down the thing. This electric field is same as the electric field due to a point charge due to a point charge capital Q kept at the I want to write kept at it's fine. 1 by 4 pi epsilon naught is how much? K. So it is KQ by R square. Same. 1 by 4 pi epsilon naught is K. Same as point charge. Copy it. Second case. Anyone writing? Second case. On the surface. On the surface means what? Small r is equal to capital R. It means the point P is on the surface itself. So small r is equal to capital R. So it means what? Electric field will be equal to KQ by small r will be replaced by what? Capital R. No need to write anything. We just write on the surface. Gaussian surface ka radius will be same as the radius of sphere. Just put small r as capital R. Done. Now the last case. Inside the hollow sphere. Inside the hollow sphere means what? Small r should be less than capital R. So if you draw the figure, let's draw the figure. So radius is capital R. Let's draw the Gaussian surface. This is the Gaussian surface. What is the radius of Gaussian surface? Smaller. Charge is on the surface. Answer one thing. What is the charge enclosed by this Gaussian surface? See the figure. What is the charge enclosed by this Gaussian surface? Nothing. Nothing. Zero. Because where is the charge? Inside or outside? Outside. The charge is outside. So there is no charge enclosed by this Gaussian surface. If charge enclosed is zero, what will be flux? Zero. I can write down the charge enclosed by the Gaussian surface is zero. So electric flux is charge enclosed by epsilon naught. So electric flux will be zero. If electric flux is zero, what will be electric field? Yes, Vachabati, if electric flux is zero, what should be electric field? Zero. What is the meaning of electric flux? Forget about formula. What is the meaning of electric flux? All the field lines which are passing through the surface perpendicularly. If I'm telling that net flux is zero, it means net electric field should be also zero. If that is also not, means you're not satisfied with that, use a formula. What is electric flux ka formula? E dot S. If this is zero, correct? It means right hand side should be also zero. Is the surface area zero? No. There is a surface area, right? 4 pi r square. Surface area is not zero. It means what should be zero? Electric field. So hence electric field should be zero. Yeah. Sunset has happened. Surya is also setting now. Chalo, take. Let's last thing. Draw the graph. Graph. So electric field and position. So what is the electric field inside? Just now we discussed. What is the electric field inside? Zero. On the surface, kq by capital R square. After that, kq by small r square. So inside, what is electric field? Zero. Okay, so this is basically what? Inside. Inside means small r is less than capital R. Electric field is zero. Now, this is capital R, small r equal to capital R. What is electric field at this point? K capital Q by capital R square. Okay, so this is basically on the surface. After that, what is happening? If you check the formula, electric field is inversely proportional to small r square. You can check the formula. Inversely proportional means what? Decreasing graph. So it will start decreasing from here. This is the graph. Inside 0, on the surface kq by capital R square, and this is for what? From here to here, outside. Means small r is greater than electric field is inversely proportional to. Understand, see again some students mug up this graph. You understand the flow, whatever you have done in the derivation, everything is done in the graph step by step. Everything, if you try to mug up, instead of eating biryani, you'll eat khichdi. You'll mix up everything in the exam. Happened. This is the starting only. Understand. When you understand and draw, you will not mix up things in the exam. And you will not feel like I have to read it every time. Students who mug up, they revise this frequently and they feel I'm forgetting of it. But the person who have practiced the derivation 2, 3 times, you can ask them to draw, they draw it very easily without putting any effort, very smoothly. You have to practice the derivation and then try to draw this graph. Okay. So this chapter is over. Now only few numericals on Gauss law is left, which we will do in the next class. So tomorrow I'm going to start the next chapter. Numericals on Gauss law we will do on Saturday. I don't want anyone to miss Saturday's the class. Okay. We'll take 5 minutes break, then we'll start maths. Students will start maths in 5 minutes. You can take a 5 minutes break.